All right, Professor Hoffman with you talking about Chapter 6. And Chapter 6 is about pressure and winds. And there are three forces that really drive the wind and how we look at wind moving around storm systems. So those three forces that we're going to be looking at. One is pressure gradient force, two is Coriolis force, and three is friction. And one of the things that our end goal here is to understand how wind flows around high pressure and how wind flows around low pressure. So this is high pressure and this is low pressure. And when we look at weather maps, in Chapter 7, we're going to talk about something that's called synoptic scale weather maps. You're going to look at what we call high pressure, which is signified by a blue H, and low pressure, which is signified by a red L. So I'm going to focus on not the entire part of Chapter 6, but I'm just going to focus on high pressure and low pressure to make sure you understand really how these forces are moving. So high pressure and low pressure. It all starts with wind flowing out of high pressure into low pressure. And this force is called the pressure gradient force, abbreviated PGF, okay? So wind is flowing out of higher pressure into lower pressure. Now, without any forces, the wind would pretty much flow in a straight line. But we have two other forces we're going to be looking at. Pressure gradient force followed by Coriolis force. And what's important about the Coriolis force is the wind is deflected to the right in the northern hemisphere because of the Coriolis force. So think about the Earth rotating, okay? Now, as the Earth is rotating, okay, this spin is going to be to the right in the northern hemisphere, to the left in the southern hemisphere, okay? So if we were looking at, here's the North Pole, here's the equator, okay? And as the Earth is spinning and rotating, okay, the force is going to go to the right. So the Coriolis force, what's important about it, it deflects the wind to the right in the northern hemisphere. Pressure gradient force is where the wind all starts off, where the wind flows from high pressure to low pressure. Coriolis force deflects the wind to the right in the northern hemisphere. Now, if the Earth didn't rotate, the wind would flow straight, but we have a rotating Earth. So Coriolis force is going to deflect the wind to the right in the northern hemisphere, not the east, west, south. It is the right in the northern hemisphere. It is to the left in the southern hemisphere. And then we have friction. Friction is very important as well because when you take pressure gradient force, Coriolis force, and friction, you're going to get a certain wind flow around high pressure and a certain wind flow around low pressure. Okay, so when you add in all these three forces, we get a wind flow that we've come to know today as wind flows around and out of high pressure into low pressure. Okay, the wind flows into low pressure and out of high pressure. So what we're going to be looking at is cyclonic wind flow and anticyclonic wind flow. Low pressure is also known as a cyclone. High pressure is not a cyclone, so it's known as a anticyclone. So when we're looking at a weather map, we want to find where high pressure is because we know the wind flow is going to flow into lower pressure. And when we talked about Chapter 4 and one of the ways to get air to rise, convergence, air coming together, air comes together in a cyclone and air rises and goes upward. So we're going to be looking at how these forces play a role. So pressure gradient force is the wind that flows from high pressure to low pressure. Coriolis force is the wind is deflected to the right in the northern hemisphere. Now friction changes its speed and direction at the surface. So when we start looking at wind speeds and what's happening high pressure and low pressure, we need to look at two locations. One is the ground, or what we also call the surface. The second part is above the ground, or what we call a loft, generally around 30,000 feet. So when you're thinking about the atmosphere, think about your feet and think about your head. You have a certain wind flow at your feet and you have a certain wind flow at your head. So we're going to look at how all these forces come together. So when you look at chapter 6, there's a lot of diagrams on showing how this air is all going to move. So again, the pressure gradient force is the wind that flows from high pressure to low pressure. The Coriolis force is the wind that deflects to the right in the northern hemisphere, to the left in the southern hemisphere. And friction changes the speed and the direction of the wind. So it's going to do two things, that friction. So when we combine all these together, this is kind of what it looks like. I'm going to do a two-dimensional and a three-dimensional look at the winds. So when we're looking at high pressures and low pressures, okay, if this is high pressure here and this is low pressure here, wind is going to flow towards low pressure. Wind flows out of high pressure. This is what we call divergence. We have diverging air out of high pressure, okay? And this is the surface, or the ground. So this is diverging air out of the surface. Now, into low pressure, wind flows out of high pressure into low pressure. This is called convergence. So at the surface, wind flows into low pressure, okay? Flows out of high pressure into low pressure. Now, when you have converging air with low pressure, air is going to rise. This is one of the principles of air rising in chapter 4. Convergence air, low pressure. One of the 4 ways we get air to rise. So you have upward motion here, rising air. Now on the top of low pressure, aloft or 30,000 feet, you're going to have air going outward. So this is divergence here. Divergence. Now everything flows in and out of some object. So what's happening here? Diverging air at the surface with high pressure, converging air into low pressure. Air goes upward, diverges out. Now air goes downward with high pressure. And so what happens when it gets close to high pressure? It's converging here. So that's convergence. So you have convergence here, and then what happens above high pressure? The air is colder, so it sinks. You have sinking air above high pressure. You have rising, warming air above low pressure. Remember what we talked about if the air is stable or unstable? If the air parcel is warmer than the environment, or if the air parcel is colder than the environment? Well, if that air parcel is warmer than the environment, air rises. That's low pressure. This is low pressure over here. Air rising upward. Air is colder than the environment above high pressure. So air is sinking. So this is going to be stable. High pressure is stable. Low pressure is unstable. So with low pressure, clouds, precipitation, condensation, okay? Those are the things we're going to be looking at. If we want to find rain or snow, we look for low pressure. If we want sunny, dry weather conditions or nice weather, we look for high pressure. So what happens when wind is flowing out of high pressure into low pressure? Low pressure, you're going to have stronger winds. You're going to have clouds and precipitation. High pressure, you're generally going to have less clouds, more sunshine, and typically light winds. So that's one of the reasons why we're always looking for where high pressure and low pressure is on a synoptic scale weather map. The maps you see on TV, the maps if you look online. Low pressure is going to add to rising air, condensation, and precipitation, wet weather conditions. High pressure, which is a blue H on a weather map, has sinking air. It has divergence at the surface, Convergence aloft, air is going down. This is stable. Less clouds, lighter winds. More clouds, better chance of precipitation, okay? Stronger winds with lower pressure. So wind is constantly flowing around. There are a couple of notes, or diagrams, I should say, in the notes, in the chapter 6 notes online and also in the book, where you can see a couple of diagrams where you have converging at the surface and diverging air aloft. So air goes into low pressure at the surface and out of low pressure above the ground. High pressure, you have air going into high pressure above the ground, and at the surface, air is going out of. So this is what we're going to be looking at. How is the wind flowing? The pressure gradient force is the wind that flows from high pressure to low pressure. Now that's just one aspect of how everything is moving. So from the ground, upward, above the ground, and back downward. So you have a constant cycle of air moving. Now when we're looking at, this chapter is about pressure and winds, well, how do we know what the wind direction is? Because of pressure gradient force, Coriolis force, and friction, we get a certain type of wind direction with high pressure and low pressure, okay? Wind flows out of high pressure into low pressure. Air rises, goes out of the top of low pressure, goes into the top of higher pressure, okay? So there's a constant cycle of movement of air. So we can always get an idea where the strongest winds are and where the lowest pressure is, because air is flowing into or converging with that lower pressure. Okay, so having an understanding, the characteristics, lower pressure overall. By the way, we measure pressure with a barometer. If you watch the videos online, you'll get more of a widespread information on the chapter. But lower pressure, measured by our barometer, we have low pressure, stronger winds, clouds, and precipitation. Higher pressure, less clouds, more sunshine, and lighter winds. So those are some of the characteristics that we'll be looking at on what we call a synoptic scale weather map. So let me erase this here. So now we can get a general concept of what the wind flow is around high pressure and low pressure. So low pressure is going to be unstable. It's going to have clouds. It's going to be having precipitation. And one key factor you need to know here, the wind is dependent on where your storm center is. So where is low pressure? We want to know where low pressure is. Because if you're over here at point 1, point 2, point 3, point 4, you're going to have a different wind direction. And that could give you different moisture, that can give you different temperatures, that can give you different types of clouds. So we always need to locate. Your wind is dependent on the storm center. Where is low pressure? And the reason why it's dependent on that is because wind flows from high pressure to low pressure. Now, because of these three forces, we get a certain wind flow around high pressure and low pressure. Here's high pressure, here's low pressure. Wind flows out of high pressure, okay? Typically like that. But when we add in these other forces, okay, we change the wind direction. Okay, I'm going to try to do this a little bit closer to what the book has it. So if this is higher pressure here, lower pressure here, wind flows from higher pressure to low pressure. Now when you add in the Coriolis force, it deflects that wind to the right. And what will happen at this point, you'll get a curvature in the wind flow. Now you add in friction. Friction only happens at the ground. So now when you add in friction, it changes the speed and the direction of the wind. So it kind of does more of like something like that. So what will happen is when we add all these features in, the wind flow kind of goes like this. Here's your cyclone or low pressure. This is cyclonic wind flow. High pressure is anticyclonic. Or anticyclone. So what will happen is around high pressure, because of pressure gradient force, because of Coriolis force, and because of friction, at the surface, At the surface, that is a key part here. At the surface, high pressure will have a clockwise wind flow. Low pressure, or our cyclone, will have counterclockwise wind flow. So this is the wind flow around low pressure. That's a counterclockwise motion. Wind flow around like this, that is a clockwise motion. So that's one of the things that meteorologists look at is what is the wind flow around high pressure and low pressure. Again, because if you're over here, your wind and weather will be very different than over here. If you're over here, your wind and weather will be very different than all the way over here. So understanding what was going on with low pressure, the wind flow, and where is the storm center. Very important. If we can figure out the storm center, we can find our cyclone, we can find our counterclockwise wind flow or our cyclonic wind flow, and then we can get an idea where high pressure is because wind flows from higher pressure into lower pressure. So that's one of the key ingredients that we're looking at here is where is the wind? How is it flowing? And one key part as well, wind is always the direction it is coming from. Wind is always the direction it is coming from. Okay, very important. So if you're looking towards the south, you get hit in the face with the wind, it's a south wind. Okay, and a south wind, south of Long Island, look towards Florida, it's warm. So typically a south wind is a warm wind and a north wind is a cold wind. So that's why it's important to understand wind direction when you're looking at storm systems, okay? The lower the pressure, the stronger the storm, okay? And think of a roller coaster, okay? On a roller coaster, you have a high part, and all of a sudden it goes down. The faster the roller coaster, the higher it starts off at. So think of this as high pressure here and low pressure here. So the difference in that pressure from high pressure to low pressure causes wind. That's one of the things we talked about on test 1. The difference in pressure causes wind. The greater the difference in pressure, the stronger the wind. So if you have a really high pressure and a really low pressure, you'll get a strong wind. That's called a steep pressure gradient. Okay, a steep pressure gradient. There's usually steeper pressure gradients with cyclones, hence why they have stronger winds, and there's typical lighter pressure gradients with high pressure, and they have lighter winds. So this is some of the basics that you're going to be looking at when you're looking at chapter 6 of understanding the wind flow around high pressure and low pressure. There's lots of diagrams there. One thing I did not talk about is pressure in general, okay? The standard atmospheric pressure is 1,023, I'm sorry, just jumping ahead, 1,013.25 millibars. That is the standard atmospheric pressure. And when you look at a weather map, okay, you may have a cyclone that is 990 millibars. You may have a high pressure that is 1,023 millibars, okay? And the bigger the difference in those storm systems, or I should say, the bigger the difference in pressure from these two areas of pressure fields, that's where you're going to be looking at whether it's stronger winds or not. A hurricane has much lower pressure, so you have strong winds. A nor'easter has low pressure, so there's strong winds. So that's one of the things you're going to be looking at. What's the pressure, okay? The lower the pressure, okay, the stronger the winds. So basically, if you're under 1,013.25 millibars, you typically have lower pressure. And the other thing that's important is that it's always relative of the pressure around you, okay? Is it the lowest pressure in this area? Is it the lowest pressure on our weather map? Where are areas of highs and lower pressures? So that's one of the things you're going to be looking at. Wind flow around high pressure is clockwise. Wind flow around low pressure is counterclockwise. Rising air, clouds, precipitation with cyclones. Sinking air, lighter winds, sunshine with higher pressures. So those are some of the basics that I just wanted to kind of go over and draw on the board and understanding the wind flow, okay? Friction changes the speed and direction at the surface. Coriolis force deflects the wind to the right. Pressure gradient force is where it all starts off, and it flows from high pressure to low pressure. And again, because of Coriolis and friction, that's how you get the clockwise flow and the counterclockwise flow with these storm systems. And one of the things that we're going to be looking at is winds flowing parallel to the isobars. What does that mean? Those are in some of the other videos and the diagrams online. So if you have any questions about this, please let me know. I just wanted to go over a quick little weather video on high pressure and low pressure, understanding the three predominant forces that move the wind. And again, friction is at the surface, so your wind's speed changes direction and slows down. But above the ground, wind speeds are much stronger, up around the jet stream level. When we talk more about that in later in chapter 6 and also chapter 7, winds above the ground around 30,000 feet, you could have winds on a daily basis around 200 miles per hour or 150 miles per hour. As opposed to the ground, friction slows down the wind. So on average, we have winds about 10 to 20 miles per hour per day. Sometimes a little less, sometimes a little bit more. So friction occurs at the ground. It changes the speed and direction of the wind. Coriolis force deflects the wind to the right, and pressure gradient force starts it off, and it's the wind that flows from high pressure to low pressure. So that's a little bit of a video. Hopefully that kind of clears some things up. If you have any questions, just send me an email, and I can go over in another video, and hopefully you understand some of the basic concepts in this chapter.